Dear student, welcome to my channel. Topic of this video is Hill Cipher for 3x3 matrix. I have already published the video for Hill Cipher in which I have taken the matrix of 2x2. Now let us start. Classical encryption technique. They are opposed to the modern cryptography, and the main aim is to understand the classical encryption technique is to introduce the basic concept and terminology of encryption and prepare us for studying the modern cryptography. So in my previous video, I have already covered all types of classical encryption technique including Hill Cipher for 2x2 matrix. In this video, the matrix is extended to 3x3. Hill Cipher, it is developed by mathematician Lister Hill. It is polyrographic substitution cipher because it encrypts block of multiple letters at once rather than single letter. This method relies on linear algebra and number theory. It encrypts the multiple letters simultaneously, making the frequency analysis more difficult. It is vulnerable to known plain text attack. That is, if attacker knows plain text and ciphertext pair, then they can solve for the key matrix using the linear algebra. Now this is the equation for encryption, that is C is equal to K into P mod 26 and P is equal to K inverse into C mod 26. Now here we require to design K as a matrix which is nothing but the key in such a way that whose inverse exists. So while solving the problem, I will clear this step. Now let us start with the example. Now this is a key matrix of 3x3. So it is GYB NQK URP and it is represented from into 0 to 25 characters, in which 0 is A and capital Z is 25. So in this way G is nothing but 6. So in this way this matrix is represented. Now our plain text is secret map. It is again converted to alphabets from 0 to 25 according to A, Z respectively. So for S it is 18. So in this way it is modified from the alphabet to number. So this is our first step. Now we'll first see the encryption. The encryption is nothing but C is equal to K into P mod 26. Now here the encryption is very easy. Now our matrix is 3x3, so we are taking the chunk of 3 characters, that is we are taking the trigram. So 6, 24, 1, 13, 16, 10, 20, 17, 15 is our K matrix, and we multiply this with 18, 4, 2. That is our first text, that is nothing but the ciphertext is nothing but the this SEC. So 18, 4, 2 we are taking. So it is actually SEC, secret map. Then here we just multiply, and as our answer is always between 0 to 25, so we are applying the mod 26 operation. So here it is after mod 26 operation, it is 24, 6, 16. So in this way we are taking first 3 characters 18, 4, 2. Then next we will take 17, 4, 19, and then we will take 12, 0, 15. So for the next character 17, 4, 19, we multiply with this K matrix. After that we will get the result. We do the mod 26 operation so that our result will come between 0 to 25. So in this way the ciphertext is converted. Now next 12, 0, 15 we multiply. Again we do the mod operation, and in this way we are converting our plain text to the ciphertext by matrix multiplication. And as our matrix is 3x3, we are taking the first 3 characters 3 characters chunk or chunk of 3 characters from the plain text. Now we see the decryption. So decryption we require to give attention. So for this decryption, whenever we design the scheme, that is nothing but our key, that is nothing but this matrix of 3x3, it should be in such a way that its inverse exists. If its inverse exists, then only encryption and decryption is possible. Now the formula is P is equal to K inverse into C mod 26. Now this is our K. Now we require to find out the K inverse. So this is the formula for K inverse, that is 1 divided by determinant of K into adjoint of K. So first we will find out the determinant. Now the matrix is 3x3. So formula for the 3x3 determinant is A into EI minus FH, EI minus FH. Middle term we take the minus B into DI minus GF, and for third plus C into DH minus EG. So we will take the corresponding elements and we will do the operation, and after the operation the answer is 441. So again it is not between the 0 to 25, so again we do the mod 26 and we will get the 25. So this is our answer, get 25. So the determinant for this 3 by 3 matrix is 25. Now this determinant is divided, so we require to take this k here, and after that we will solve with the mod operation to get the value. Now k equal to 25. Key selection condition: the determinant of the key matrix must be non-zero and co-prime to 26 for it to have inverse in modulo 26. So these two conditions must be met. Now 25 and 26 are co-prime to each other because when we calculate their GCD it is equal to 1. So here we can write down this equation, that is k, that is this k is nothing but determinant into k inverse, and they are co-prime to each other. So we can write down determinant into k inverse congruent to 1 mod 26. Now this k is 25, so we will solve for the extended GCD algorithm. So I have already published the video for extended GCD. So for this you should have the knowledge of how to calculate the extended GCD. To understand this method you should know how to calculate the extended GCD to calculate values. So GCD of 26 and 25. So 26 is equal to 25 into 25 1 into 1. So this is nothing but the coefficient and this is nothing but the variable. So in this way we calculate. So we are getting the answer as a -1, but we don't want -1 answer. So we again take the positive. So -1 is equal to 26 -1 plus r. This is only one sign. I have already explained the method, so better you check the previous video, or if you understand this method then it is very easy. Then we are getting r equal to 25. So in this way we come to the first step, that is we calculated the determinant, and next we require to find out the adjoint. Now for the adjoint, for 3 by 3 the matrix formula is, that is we require to calculate the cofactor, and for each cofactor we require to give the sign like this. Now we will see the example directly. Now first we require to take plus, minus and plus. So we are taking, this is nothing but the 16, 25, 17 take, and we are taking the positive sign for this. So we are getting the 17. For the second our sign is negative, so we require to take this element. So we will skip this middle. So 13 into 15 and 20 into 10. So we are getting the 5. For the last sign is plus, so 13 into 17 minus 20 into 16. So we are getting the minus 99. So we have calculated the row 1. Next we will calculate the row 2. So for the row 2 we will skip this and we are taking the sign minus, plus and minus. Now we will take the first minus. Then what we require to do, that is, as here we will skip the first. So 24 into 15 minus 17 into 1, and our sign is minus. Then next we require to skip the middle one. So 6 into 15 and 20 into 1. So we are taking corresponding this element. And for third we will skip the last. So 6 into 17 minus 20 into 24. So for the first and last element the answer is -1 because its minus sign is there. So in this way we will do for the row 3. So for row 3 our signs are plus, minus, plus. So for row 3 we will skip this particular first. So we have to take skip the first. So it is 24 10 minus 16 into 1. Then next we require to take, this is the plus sign. So plus 24 1 16 10. Then next is the minus sign. So minus sign, and here we require to take the first and third. So we'll skip the second. So 6 1 13 and 10. So in this way we will get the minus 47. Then next is the plus sign. So here plus. Now we require to skip that last. So here the element will come as a 6 24 and 13 16. So 6 into 26 into 16 minus 13 into 24. So in this way we calculate the cofactor. So this is nothing but the adjoint k. Then we require to take, these are the cofactors, and adjoint is nothing but the transpose of the cofactor. So we just apply the transpose operation and we are getting this value. Now here some values are positive and some values are negative, and even some values are exceeding between the 0 to 25. So we again apply the mod 26 operation, and after applying the mod 26 operation we are getting this matrix. So you should have, if the value is negative, how to take the mod operation. So I have published the video on such a simple topic also. So you just check that to understand this video in a smooth manner. Now this is only to cross check. This is no need to solve in the exam. Only I have to say that the encryption and decryption is possible only when the matrix, that is K is nothing but our secret key and its inverse must exist, then only the encryption and decryption is possible. Now here we multiply. Now finally K inverse is nothing but the determinant into adjoint. By extended Euclidean we are getting the determinant as 25, and this is nothing but our transpose of the cofactor matrix, and which is kept between the 0 to 25. So this is the matrix. So we multiply. Again the values are exceeding. Again we apply the mod 26 operation. This is our matrix. Now we multiply, that is our original key and the K inverse, and after multiplying again the value exceeds. Again we apply the mod 26 operation and we are getting 0. That is the identity matrix 1 1 1. So that means what? It inverse exists, and this proves that the encryption and decryption is possible. So that's why we want to design the key in such a way that its inverse should be, or inverse must be present, then only this scheme will work. So in exam it is not required to cross check this K into K inverse, because whenever the problem is given in exam, it is already having the inverse, that is K inverse is present. Now with the decryption, so decryption now is again very easy like encryption. Once our K inverse matrix is ready, so this is our K inverse matrix. So we are taking this matrix and the cipher text, and we are getting the again 18. Again we do this simple matrix multiplication, and after that again values are exceeding, or they are not between 0 to 25. So again we apply the mod 26 operation. We are getting this. So we are getting again the original secret key, that is our plain text is secret map. So we are getting the first 3 characters. Next, this is the simple step. Now again we are taking this K inverse. Next, cipher text characters multiply, then again apply the mod 26 operation, and we are getting the next 3 plain text character, that is nothing but the map. I guess, okay, 1 minute. This is not actually by mistake, but next character we will got here, that is first is SECRET, and then next is nothing but the map character. So here it is nothing but the RET. So we are getting the original plain text after applying the decryption operation. So this is all about the Hill cipher for 3 by 3 matrix. Thank you.